everyone, let me welcome you to another important session of this crash course जहां हम डिस्कस करने वाले हैं अबाउट हाइब्रिडाइजेशन। हाइब्रिडाइजेशन केमिस्ट्री का एक बहुत इंपॉर्टेंट टॉपिक है क्योंकि हाइब्रिडेशन के हेल्प से ही हम मॉलिक्यूल्स की ज्योमेट्री शेप को प्रेडिक्ट कर सकते हैं। अगर मैं एग्ज़ाम के पॉइंट ऑफ व्यू से बात करूं तो भी ये बहुत इंपॉर्टेंट है क्योंकि हर साल एक न एक क्वेश्चन तुम्हें या तो हाइब्रिडाइजेशन पे डायरेक्टली या ज्योमेट्री या शेप ऑफ द मॉलिक्यूल से पूछता है। तो चलिए लेट्स अनलॉक द मिस्ट्री बिहाइंड द केमिस्ट्री ऑफ हाइब्रिडाइजेशन। सो लाइक आई सेड, हाइब्रिडाइजेशन बहुत इंपॉर्टेंट टॉपिक है, तो पहले हमें समझना होगा कि हाइब्रिडाइजेशन होता क्या है। सो हाइब्रिडाइजेशन इज नथिंग बट मिक्सिंग ऑफ एटॉमिक ऑर्बिटल्स। हाइब्रिडाइजेशन क्या है? हाइब्रिडाइजेशन इज मिक्सिंग ऑफ एटॉमिक ऑर्बिटल्स। अब अगला क्वेश्चन, क्या सारे एटॉमिक ऑर्बिटल्स मिक्स होंगे? तो आंसर है नहीं। इट इज नॉट मिक्सिंग ऑफ ऑल द एटॉमिक ऑर्बिटल्स, इट इज मिक्सिंग ऑफ एटॉमिक ऑर्बिटल्स हैविंग सिमिलर एनर्जी, हैविंग सिमिलर एनर्जी। अब अगर सिमिलर एनर्जी वाले एटॉमिक ऑर्बिटल्स मिल रहे हैं तो मिलने से क्या होगा? तो मिलके वो नए ऑर्बिटल्स प्रोड्यूस करते हैं। Mixing of atomic orbitals having similar energy to produce orbitals, और इन ऑर्बिटल्स की खासियत ये होगी that they will have same shape and same energy. Produce orbitals having same shape and energy. अब ये जो ऑर्बिटल्स मिले, these orbitals which you have got, these orbitals are known as hybridized orbitals. These orbitals are known as hybridized orbital. Okay, these orbitals are known as hybridized orbital, and these hybridized orbital only will be used in the formation of bond. And when hybridized orbital is used or involved in bond formation, it forms sigma bond. So I can write hybridized orbitals are used in the bond formation. What type of bond is formed? So it forms sigma bond. Hybridized orbitals form sigma bond. Next, now the atomic orbital which are undergoing hybridization, should they have unpaired electron, or they should be vacant, or they should have lone pair of electron? What should be the condition? So point is all three, whether they are vacant or singly occupied or fulfilled, all of them can undergo hybridization. So that also we can write atomic orbitals which are vacant, singly occupied or fully filled, can undergo hybridization. Now, based on the atomic orbitals which are used in hybridization, we name different types of hybridization. So next is types of hybridization, and this type is based on the atomic orbitals which are used, type of hybridization. Acha, before that you should be clear that number of hybridized orbital will always be equal to number of atomic orbitals involved in hybridization. Number of hybridized orbital number of hybridized orbital will be equal to number of atomic orbitals undergoing hybridization. If two atomic orbitals are undergoing mixing, then two hybridized orbital will be formed. If three atomic orbitals are undergoing mixing, then three hybridized orbital will be formed. चलो अब स्टार्ट करते हैं different types of hybridization, जिसमें फर्स्ट वन है sp hybridization. फर्स्ट वन क्या है? sp hybridization. sp hybridization का मतलब हुआ एक s ऑर्बिटल और एक p ऑर्बिटल हाइब्रिडाइज होगा. अगर एक s और एक p मतलब टोटल टू ऑर्बिटल्स हाइब्रिडाइज हो रहे हैं, सो वी कैन राइट टू हाइब्रिडाइज्ड ऑर्बिटल्स विल बी फॉर्म्ड. टू हाइब्रिडाइज्ड orbitals will be formed, and these two hybridized orbitals, as we know, will have same shape and same energy. अब ये अपने आप को अरेंज कैसे करेगा? सो लेट्स से दिस इज अ सेंट्रल एटम m, तो इसी का हाइब्रिडाइजेशन हो रहा है. सो एक ऑर्बिटल मेरा ऐसा होगा और दूसरा हाइब्रिडाइज्ड ऑर्बिटल में दूसरी साइड होगा कुछ इस तरह से. ठीक है, और ये दोनों जो होगा ये एक दूसरे के बिल्कुल ऑपोजिट होगा. तो मैं बोल सकता हूँ ये अलोंग अ लाइन होगा. सो दिस अरेंजमेंट विल बी नोन एज लीनियर ज्योमेट्री. इस अरेंजमेंट को क्या बोलेंगे? दिस अरेंजमेंट विल बी नोन एज लीनियर ज्योमेट्री. व्हाट अबाउट दिस एंगल? सो ये एंगल जो मेरा होगा, दिस एंगल विल बी 180 degree. This is about sp hybridization. This is also known as diagonal hybridization. This is also known as diagonal hybridization. sp hybridization is also known as. Next one is sp2 hybridization. तो नेक्स्ट वन देख लेते हैं. नेक्स्ट इज sp2 hybridization. sp2 hybridization. Now as the name suggests, sp2 मतलब क्या हुआ? एक s orbital and two p orbitals are used. So we can say total 3 atomic orbitals are used. So 3 hybridized orbitals will be formed. 3 hybridized orbitals will be formed. Next, जो 3 hybridized orbitals होंगे वो अपने आप को अरेंज कैसे करेंगे? So they will arrange themselves in space in this manner. So this angle will be 120 degree. And if I join these three, they'll form a triangle. That's why this geometry is known as trigonal planar geometry. This geometry is trigonal planar geometry. इसके बाद थर्ड वन जो हम लोग देखेंगे वो है sp3 hybridization. sp3 hybridization जैसा कि नाम से पता चल रहा है, 1 s orbital and 3 p orbitals will be used. So I can write total 4 hybridized orbital. 4 hybridized orbitals will be formed. 4 hybridized orbital will be formed. अब ये 4 hybridized orbital अपने आप को अरेंज किस तरह से करेंगे? So it will arrange themselves in space in this manner. ये इस तरह से अपने आप को अरेंज करते हैं. इस तरह से करेंगे कि मैं अगर इन सबको ज्वाइन कर दूं तो जो अरेंजमेंट होगा वो एक टेट्राहेड्रल की तरह दिखेगा. इन सबको ज्वाइन कर दूं तो कैसे दिखेगा? This will look like a tetrahedral. So this geometry is known as tetrahedral geometry. And tetrahedral geometry में किसी दो ऑर्बिटल के बीच एंगल देखोगे तो आएगा 109 degree and 28 minutes. This is about sp3 hybridization. इसके बाद जो नेक्स्ट आता है वो होता है dsp2 hybridization. dsp2 में जैसा नाम से पता चल रहा है एक d ऑर्बिटल होगा, एक s ऑर्बिटल होगा एंड एक p ऑर्बिटल होगा. तो टोटल दो p ऑर्बिटल होंगे. तो टोटल कितने हो गए? टोटल 4 एटॉमिक ऑर्बिटल्स हो गए. इसलिए हम बोलेंगे 4 हाइब्रिड ऑर्बिटल्स और 4 हाइब्रिडाइज्ड ऑर्बिटल will be formed. 4 hybridized orbitals will be formed. अब जब मैं d बोल रहा हूं तो मुझे भी पता होना चाहिए कि कौन सा d ऑर्बिटल यहां पर यूज होता है। तो यहां पे d x² y² होगा, s होगा, px होगा एंड py. These are the 4 orbitals which are used for this hybridization. और जो ऑर्बिटल्स होंगे वो अपने आप को कुछ इस तरह से अरेंज करते हैं। ऑर्बिटल्स अपने आप को कुछ इस तरह से अरेंज करते हैं। तो अगर मैं इन सबको ज्वाइन करूं तो मुझे एक स्क्वायर मिलेगा। ठीक है, सो दैट्स व्हाई दिस अरेंजमेंट इज नोन एज स्क्वायर प्लेनर अरेंजमेंट और स्क्वायर प्लेनर ज्योमेट्री। और जो एंगल होगा यहाँ पे, ये एंगल होता है मेरा 90 डिग्री। दिस इज अबाउट DSP2 हाइब्रिडाइजेशन। फिफ्थ वन जो होता है वो होता है sp3d हाइब्रिडाइजेशन। फिफ्थ वन क्या है? sp3d हाइब्रिडाइजेशन। तो यहाँ पे नाम से पता चल रहा होगा एक s ऑर्बिटल यूज होगा, 3 p ऑर्बिटल्स यूज होंगे एंड 1 d ऑर्बिटल will be used. So total 5 atomic orbitals are used. So we can write 5 hybrid orbitals. 5 hybrid orbitals will be formed. अच्छा, यहाँ पे कौन कौन से ऑर्बिटल्स यूज होंगे? तो s, px, py, pz and dz². These are the 5 orbitals which are used in sp3d hybridization. अब अपने आप को अरेंज कैसे करेगा ये 5d ऑर्बिटल्स? सो ये देखो, ये जो 3 एटॉमिक ऑर्बिटल्स मैं ड्रॉ कर रहा हूँ, ये 3 एटॉमिक ऑर्बिटल्स विल बी इन अ प्लेन। दे विल बी इन अ प्लेन। सो इसको अगर ज्वाइन करूँगा तो मुझे एक ट्राइंगल टाइप अरेंजमेंट दिखेगा। अब इस ट्राइंगल प्लेनर अरेंजमेंट के ऊपर एक होगा ऑर्बिटल और इसके नीचे होगा एक ऑर्बिटल। अब ये जो ऊपर वाला है और ये जो नीचे वाला है, इन दोनों को क्या बोलते हैं? इन दोनों को बोलते हैं एक्सियल पोजीशंस। और ये जो तीनों मेरा एक प्लेन में है, इन ऑर्बिटल्स को क्या बोलते हैं? इक्वेटोरियल ऑर्बिटल्स। सो एक्सियल ऑर्बिटल्स एंड इक्वेटोरियल ऑर्बिटल्स। इंपॉर्टेंट पॉइंट इज length of axial orbital. Length of axial orbital is more than equatorial orbitals. Length of axial orbital is more than equatorial orbital. Strength की हम बात करेंगे तो strength will be just opposite. Axial will be weaker and equatorial will be stronger. Next हम बात करते हैं एंगल। तो ये जो एंगल यहाँ पे होता है between the equatorial orbitals, this angle will be 120 डिग्री। और ये जो एंगल होगा between axial and equatorial, ये एंगल क्या होगा? ये होगा मेरा 90 डिग्री। So these are the different angles which are present in sp3d hybridization. इसके बाद नेक्स्ट जो आता है वो होता है sp3d2 hybridization. नेक्स्ट वन क्या होगा मेरा? sp3d2 hybridization. sp3d2 hybridization में जैसा कि नाम से पता चल रहा है, 1s orbital, 3p orbitals and 2d orbitals are used. So total 6 atomic orbitals are used. So we can write 6 hybrid orbitals. 6 hybrid orbitals will be formed. Next point, which all atomic orbitals are used? So s, px, py, pz, dx² y² and dz². These all atomic orbitals will be formed. Now how they will look? So if I draw the coordinate axis like this, let's say if I draw the coordinate axis like this, let's say this is x-axis, this is y-axis, this is z-axis, then the orbitals will be like this. 2 on the x-axis, 2 on the y-axis and 2 on the z-axis. This is the arrangement, or we can draw it like this also. M. This arrangement of orbitals is known as octahedral arrangement. So this geometry is known as octahedral geometry, or we can also call it as square bipyramidal geometry. Square bipyramidal. I guess I forgot about previous one. sp3 dehybridization. This geometry is known as trigonal bipyramidal geometry. This geometry is known as trigonal bipyramidal geometry. Trigonal bipyramidal geometry. And sp3d2 will be octahedral or square bipyramidal geometry. What will be angle between any two orbitals? So between any two orbitals, the angle is 90 degree. So possible angles are 90 degree and 180 degree. Okay, fine. Next one, if we talk about seventh one. Seventh is sp3d3 hybridization. sp3d3 hybridization. So in this, as we can see, one s orbital, 3p orbital and 3d orbitals are used. It means total 7 atomic orbitals are used, which means 7 hybrid orbitals. 7 hybrid orbitals will be formed. Which all atomic orbitals are used in this? तो s होगा, px होगा, py होगा, pz होगा. अब इसके अलावा d के 2 सेट्स पॉसिबल हैं. या तो dxy, dyz या dxz हो जाए, या फिर dxy, dx square y square and dz square हो जाए. So these are the atomic orbitals which are used in sp3d3 hybridization. अब इसकी ज्योमेट्री को अगर देखें तो 5 atomic orbitals जो होंगे, I'm drawing with the help of lines. So these are the 5 atomic orbitals which will be present in a plane. One will be above this, one is below. So if we join all these 5 orbitals which are present in a plane, it will form a pentagon. So that is why this geometry is known as pentagonal bipyramidal geometry. Pentagonal bipyramidal geometry. And what will be angle in this case? So one possible angle is 72 degree, other possible angle is 90 degrees. So two angles are possible in sp3d3 hybridization. One is 72 degree, other is 90 degree. So this is about different types of hybridization. Now next is how to find hybridization of central atom. How to find hybridization of central atom. तो आपको मैं बहुत सिंपल सा तरीका बताता हूं. जो हाइब्रिडाइज्ड ऑर्बिटल्स हैं, हाइब्रिडाइज्ड ऑर्बिटल्स, इनका दो काम होता है. हाइब्रिडाइज्ड ऑर्बिटल दो जगह यूज में आते हैं. पहला यूज आता है फॉर्मेशन ऑफ सिग्मा बॉन्ड, फॉर्मेशन ऑफ सिग्मा बॉन्ड, और सेकंड यूज आता है accommodate lone pair of electron. Accommodate lone pair of electron. So ये काम है hybridized orbital का. अब for formation of one sigma bond, one hybridized orbital is required. For accommodating one lone pair of electron, again one hybridized orbital is required. Now let's say a molecule forms 3 sigma bond and the central atom has one lone pair of electron. So they will ask what is the hybridization of the central atom. So we can see that there are 3 sigma bond. So for formation of 3 sigma bond, we need 3 hybridized orbital, and there is one lone pair of electron. So for accommodating one lone pair, we need one hybridized orbital. So in total, we can see that total 4 hybridized orbital will be required, and 4 hybridized orbital is present in sp3 hybridization. That is why hybridization of central atom will be sp3. Let's take one more example. Let's say a central atom in a molecule forms 3 sigma bond and has 2 lone pair of electrons. So what is the hybridization? So again we can see for formation of 3 sigma bond, we need 3 hybridized orbital, and for accommodating 2 lone pair of electron, again we need 2 hybridized orbital. So in total 5 hybridized orbital is required, and 5 hybridized orbital are present in sp3 dehybridization. So that's why the hybridization of this central atom will be sp3d. So if you know number of sigma bonds and number of lone pairs, we can easily find the hybridization. Now next is how to find number of sigma bond. So we can write number of sigma bond is equal to number of terminal atoms. Number of sigma bond is equal to number of terminal atoms. Now let's see some examples, then it will be more clear. I'm taking some compound like PCl5, PCl3, SF2, SF4, SF6, XCF6, XCF4, XCF2. So we'll see how many sigma bonds are present in each case. Number of sigma bonds. So as I have told you, number of sigma bond is equal to number of terminal atom. Now in first case PCl5, terminal atom is chlorine, central atom is phosphorus. So 5 chlorine atoms are present. So that's why I'm writing 5 sigma bond will be there. PCl3, phosphorus is central atom, chlorine is terminal atom. There are total 3 chlorine terminal atoms. That's why number of sigma bond will be 3. Same way, in SF2, sulfur is central atom, fluorine is terminal atom. There are 2 terminal atoms, that's why 2 sigma bond. Same way if you do for SF4, we'll have 4 sigma bond. SF6 will have total 6 sigma bond. XCF6 again will have total 6 sigma bond. XCF4 will have total 4 sigma bond, and XCF2 in total will have 2 sigma bond. So like this we have calculated how many sigma bond is present. Next is how to find lone pair. Now, if you see phosphorus in its outermost shell will have total 5 electrons. And what we can see that all 5 electrons are used in sigma bond formation. So no electrons are left. If electrons are not left, lone pair will be 0. Same way if you see PCl3, phosphorus has 5 electrons in its outermost shell, and out of 5, 3 are used in sigma bond formation. So how many electrons will be left on phosphorus? 2. So 2 electrons means we'll have 1 lone pair. SF2, sulfur in its outermost shell has total 6 electrons. Out of 6, 2 are used in this sigma bond formation. So how many are left? 4. And 4 means we'll have 2 lone pair. Same way SF4, sulfur has 6 electrons in its outermost shell, and out of 6, 4 are used in sigma bond formation. So we will be left with just 1 lone pair of electron. In case of SF6, all 6 electrons are used in sigma bond formation. So lone pair left is 0. XCF6 will have 1 lone pair. XCF4 will have 2 lone pair. XCF2 will have total 3 lone pair of electrons. So like this we have calculated number of sigma bond and number of lone pair. And if these things are clear, we can find the hybridization. Now 5 plus 0, total 5 hybrid orbital will be present in sp3d. 3 plus 1, 4 hybrid orbital will be present in sp3 hybridization. 2 plus 2, 4 again sp3. 4 plus 1, 5. It means sp3d. 6 plus 0, 6 means sp3d2. 6 plus 1, 7. It means it is sp3d3. 4 plus 2, 6. It means sp3d2. 2 plus 3, 5 means sp3d. So we know the hybridization of central atom in all these cases. If hybridization is known, we can also find the geometry of the molecule. sp3d means trigonal, bipyramidal. sp3 means tetrahedral. Again sp3 means tetrahedral. Next one is sp3d. It means trigonal, bipyramidal. sp3d2 means it will have octahedral geometry. sp3d3 means pentagonal, bipyramidal. sp3d2 means octahedral, and sp3d means trigonal, bipyramidal. So like this we can find the geometry hybridization of any molecule. Now let's take one example like I3 minus. So in I3 minus there are 3 iodine atoms, out of which one will be central, remaining 2 will be terminal. So if 2 terminal iodine are there, so number of sigma bond will be 2. Now how many lone pairs? Now iodine in its outermost shell has total 7 electrons. Negative charge means it has gained one more. It means it will have total 8 electrons. And out of 8, 2 are used in this hybridization. So how many lone pairs will be left? There will be left, it is having 3 lone pair. So 2 plus 3 means 5. 5 means it will be sp3 dehybridization. And sp3 dehybridization means geometry will be trigonal, bipyramidal. So like this you can find the sigma bond and lone pair. Next, another important point is oxygen and nitrogen. Oxygen and nitrogen forms 2 and 3 bonds respectively. Oxygen and nitrogen forms 2 and 3 bonds respectively. For example, if you see SO3, so number of sigma bond will be 3 because 3 terminal atoms are present. But when I'm finding the number of lone pair, in that case we have to consider the sigma bond as well as pi bond which is formed by the terminal atoms. So each oxygen, as we know, will form how many bonds? 2 bonds. So 3 oxygen in total will form 6 bonds, and we know sulfur has 6 electrons in its outermost shell. It means all the 6 electrons which are present in outermost shell will be used in bond formation. So how many lone pair will be left? So we'll be left with 0 lone pair. 0 lone pair means what will be hybridization? 3 plus 0 is sp2. And if hybridization is sp2, what will be geometry of the molecule? So geometry will be trigonal planar. So like this we can find the hybridization of the central atom. So I hope आज का जो concept था that is clear to all of you. I have given few problems. Now you can try more problems based on this concept. You can check previous year questions of JEE Mains also to see what is the type of question which they are framing based on hybridization, and you can solve them. If you have doubt, you can comment in the comment section. I will answer your questions. And if you have understood the concept properly, then please do hit like button and subscribe the channel and press the bell icon for further notification. Thank you.